holidays. What was the topic which we are talking? Yes.
Principal.
What was the topic? Increase sequence. Remember this?
Increasing.
Yes. So we were
Yes,
talking
sir.
about monotonically increasing. The sequence xn is said to be monotonically increasing if xn is less equal xn plus 1 for right. So xn is less equal xn plus 1 for all n means what? E that is x1 is less than or equal to x2, right? N is equal to 1. Same thing is true for n is equal to 2 means x2 is less than or equal to x3, x3 is less than or equal to x. Okay. Yes, so x1 is less than or equal to x2, x2 is less than or equal to x3 and so on. And therefore you choose any term and then you will find that x4 xn is less than or equal to xn plus 1. Right. So for example, if you look at minus 1 by n, is it monotonically increasing?
Yes, sir.
Yes, right. So minus 1 by n, because what is the first term? What is x1? What is x2? What is x3 and so on. So x1 is minus 1, x2 is minus half, x3 is minus 1 by 3. We know that minus 1 is less than or equal to minus half. So this is true in this case, right? Or if you look at xn and you look at xn plus 1. So what is xn is 1 by minus 1 by n, and what is xn plus 1 minus 1 upon n plus 1, which is true, right? So this sequence is monotonically increasing. Similarly, you think about this, because how will you write down the proof of third one or any? So it is monotonically increasing because n plus 1 is greater than n for all, correct? Therefore, 3 times n plus 1 is greater than 3 times n, right? That means 1 upon 3 times n is less than actually 1 upon 3 times n plus 1, correct? Multiplied by 2.
Sir, 1 upon 3 3n would be greater than 1 upon 3n.
1 upon uh, okay, right. So here greater 1 upon 3n times here it is yes, 3 times n plus 1. Now if I multiply by minus 1, what will be the inequality? Minus 2 upon 3 times n plus 1 and minus 3 times n. So in this case, what? This would be greater, right? And then add 1 and 1 minus 2 upon 3 times n plus 1. So this is true. But ultimately what we get n and this is xn plus 1. So ultimately we get that xn is less than xn plus 1. This is true for each n, therefore this sequence is monotonically increasing. Is it clear?
Yes, sir.
Yes, sir.
But in minus 1 raised to n, this sequence x1, x2, x3, x4, and so on is minus 1, 1, minus 1, 1. So it is not true that key x previous term is smaller than next term. That is not true in this case, right? In this case, it is true, but here again, opposite. Here, opposite. So, situation is like that. So, not right. We discussed this xn is equal to 1 plus 1 by 2 plus 1 by n. So is x1 is 1, right? What is x2? What is x2?
1 plus 1 by 2.
Right. What is x3? 1 plus 1 by 2 plus 1 by 3. Right. And therefore, what is x10? 1 plus 1 by 2 plus 1 by 3 up to 1 by 10 and so on. These are the numbers. Now, if you look at xn plus 1, so it is 1 plus 1 by 2 plus 1 by 3 plus 1 by n plus 1 by n plus 1. This is xn plus 1, whatever is it. And what is xn? 1 plus 1 by 2 plus 1 by n, whatever is n, 10, 100, whatever. Then next term is this. Then what is xn plus 1 minus xn? What is difference? Right?
1
1
upon n
plus
plus 1.
1 by upon n plus minus xn plus 1 minus xn. So 1 plus 1 by 2 up to 1 by n. Same n I am saying n plus 1 n. So up to 1 to 1 by n and 1 to 1 by n. So cancels. What remains only 1 upon 1 n plus 1, which is a positive quantity. So difference of two successive terms is a positive quantity and therefore ultimately xn plus 1 minus xn is positive. That means
आता काय म्हणणार आहे कोणाला केलं ना इन्स्टॉल केलेलं आहे हे बघ.
your mic off, Vedanti. Your mic off. Right, so this is true for each n, right? So just a minute. Okay, so is true for all n, right? So this sequence, this is also monotonic increasing. So is it clear? Yes.
Yes.
Okay. Now, what could be the another type of sequence? Because here terms are increasing, right? Next term is bigger than previous term. So, therefore, a sequence xn is said to be monotonic decreasing or monotonically decreasing if xn is greater than or equal to xn plus 1 for all n. Right. So what is the difference here? What is the difference in monotonic increasing and monotonic decreasing?
Each successive term is less than the previous term.
Right. So the successive term, next term less than or equal to previous term. So that is x1, x2. x1 is greater or equal x2. x2 is smaller than x1. x3 is smaller than x2 and so on. Right. So this is true at each n. Right. So this is monotonically decreasing sequence. So for example, if you look at xn is equal to 1 by n, what can you say about this sequence? What is the first term? What is second term? What is third term? What is nth term? What is n plus first term and so on. So what is the first term? 1. What is second term?
1 by 2.
Right, 1 by 3 and so on. What is the nth term? 1 by n. N plus first term is 1 by n plus 1. If we compare, 1 is greater equal half. Right. We can say greater equal, strictly greater in this case, but anyway. And therefore, what can you say about this 1 by n? 1 by n is monotonic decreasing. Is monotonic, right? Because what? Why? Xn is greater equal xn plus 1, which is true for all n, right? Now, if you look at sequence minus 1 raised to n, is it monotonic decreasing?
No, sir.
No, sir.
So 1 minus 1. So therefore neither monotonic increasing nor decreasing. Right, so this sequence is neither increasing because minus 1, then 1. So 1 is larger, then again minus 1, again 1. So it is kind of oscillating. Right, so this is going up, going down again. Right. Now if you look at sequence 1 plus 1 by n, what about this sequence?
Monotonically decreasing.
Decreasing, right? Because x1, x2, x3 and so on. So first term is 2, second term is 1 plus half, next term is 1 plus 1 by 3. So nth term is 1 plus 1 by n, and n plus first term is 1 plus 1 by n plus 1. And if you compare, then terms are decreasing, right? Because n plus 1 is greater than n, therefore 1 by n plus 1 is less than 1 by n, and therefore minus 1 by n plus 1 is greater than minus 1 by n. And if we add 1 throughout, inequality remains same. So 1 minus 1 by n and 1 minus 1 by n plus 1. Right. So
Sir, our sequence is 1 plus 1 by n.
1 plus, right. Our sequence is 1 plus, so no problem here. So if we add 1, then what remains? This is smaller. That means xn is greater equal xn plus 1 for all n. So therefore this is monotonic decreasing. Now sequence xn is said to be monotone sequence. A sequence xn is said to be a monotone sequence if it is either monotonic increasing or monotonic decreasing. If it is either monotonic increasing or monotonic decreasing. Right, so sequence is monotone sequence if it is either monotonic increasing or decreasing, whichever is it is called as monotone sequence. Right, so definition of monotone sequence is clear. Okay.
Sir,
Yes.
sir, then the constant sequence, is it a monotonic increasing or monotonic decreasing?
Right, it is both. If xn is constant sequence C, right, that means it is C, 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 every term is constant sequence. Right, is constant sequence is both monotonic because you can say that C is less equal C, x1 is C, x2 is C, right? Constant is both monotonic increasing and monotonic decreasing. Right, so constant sequence is both monotonic increasing and monotonic decreasing.
Sir, then it cannot be
Okay.
considered as monotone sequence, no?
No. It is monotonic increasing as well as monotonic decreasing, both, no problem. What is a monotone sequence? Monotone sequence means sequence which is either increasing or decreasing. Maybe both.
Okay, sir.
If both, then no problem. Still, it is monotonic. Either one of them is satisfied, that is fine. If both think that is which is a constant, and it is possible. Okay, so one more thing you can say it is a note. One, if xn is both monotonic and monotonic decreasing. Suppose xn is a sequence, it is both monotonic increasing and monotonic decreasing. Then what can you say about sequence x? What can you say about sequence xn? Is it constant?
Yes, sir.
Then xn
Yes.
must be constant because you are saying that x1 is less than or equal to x2 and x2 is less than or equal to x1. Then x1 is equal to x2, right? So same thing for x2, x3 and so on. So xn is constant, right? So okay, so definitions clear.
Yes, sir.
Yes, sir.
Right, all of you know bounded sequence, right? Now, what is the sequence or significance or importance of monotone sequence? So, what is the importance of monotone sequence? and that is important theorem, that is monotone convergence theorem. Monotone convergence theorem. Theorem says, now if you are saying that sequence is monotonic increasing, suppose xn is less than or equal to xn plus 1, sequence is monotonic increasing, then what will happen? So terms are increasing, right? First term is here, second term is here, third term here, terms are going on increasing. And where these terms will go, where the sequence will settle, where what will be the limit, what do we expect? Do you understand? It sequence is suppose increasing, monotonic increasing, right? That means terms are increasing. So next term is larger, again next term is larger. So terms are increasing. What do you expect? Where terms will go now?
Infinity.
Right. It may happen that terms will go to infinity. Right? But if some number is there which is a bound of all these terms are increasing, but all terms are less than some number. If such m is there, somebody is there who controls all the terms. Do you look at the previous example? Can such situation arise? The terms are increasing, still some number is there which will control all the terms. Just recall the examples which we seen just few minutes back. Okay, look at this sequence 1 minus 1 by n. Is it increasing?
Yes, sir.
Right, so you look at x1 is strictly less than x2 is strictly less than x3. This situation is possible at each stage, right? Do you realize this?
Yes, sir.
Yes.
And moreover, one more thing is happening ki all terms are less equal to. All terms are less equal 1 basically, correct? All terms are less equal 1. Is it true?
Yes, sir.
That means even all terms are increasing, but there is somebody who controls all the terms, which is a bound, upper bound for these terms. That is possible, right? If terms are increasing, still somebody can stop the terms. Right. But on the contrary, if you look at sequence yn, which is 2n, is it monotonic increasing?
Yes, sir.
Yes, right. Because what is first term y1, y2, y3? If you look at this, y1 is 2, y2 is 4. Right. So terms are increasing, but there is no number. There is no any number m which will control all these yn. Do you realize this? There is no number which will control all these terms. Is it possible? Right, so this is the difference between these two sequences, 1 minus 1 by n and 2n. So, what is now one more difference? What is one more difference you observe in these two examples, xn and yn? What is the difference? So, question is,
In
if
xn, every number is less than 1, and in yn, every number is greater than 2.
that is fine, but what is the limit of yn? Is yn convergent?
Divergent.
Divergent, right?
Yes.
And is xn convergent?
Yes, sir.
Yes. 2, 1.
By algebra of
Yes, sir.
by algebra of limit, we know that limit of 1 minus 1 by n is limit of 1 minus limit of, right? So limit of 1 minus 1 by n is limit of 1 minus limit of 1 by n, and we already know that limit of 1 by n is 0 and limit of constant sequence 1 is 1. So limit of this sequence is 1, so it is convergent. So even both are monotonic increasing, one is convergent and another is divergent. Why this happening? Why
Because the
this happening?
first one is having an upper bound.
Yes, because the tendency of first sequence is increasing, tendency of second sequence is also increasing, but for first sequence there is somebody who can stop them, but for second sequence there is nothing which can stop the sequence yn, right? That is the difference, right? And therefore first sequence is monotonic increasing and bounded above, and second sequence is monotonic increasing but not bounded above. That is the difference, correct?
Yes, sir.
Now we are in a position to state the theorem, and you can tell me what should be the statement of theorem. What should be the statement of theorem from this observation, these two examples? What should be the statement? Let xn be a monotonic increasing sequence. When it will converge? What guarantees, what assures that xn is convergent?
If it is bounded, then
Yes, if it is bounded above, because tendency is increasing. Bounded below is obvious thing, right? Because if you look at monotonic increasing sequence, and then tendency is increasing. See, x1 less than x2 and so on. So x1 is a lower bound, that is clear. So if sequence is monotonic increasing, certainly it is bounded below. Question is whether it is bounded above. That makes difference, right? So if xn is bounded above, then xn is convergent. Right. So suppose sequence is monotonically increasing, what guarantees the convergence if it is bounded out? Now second statement, what can you say the same thing for decreasing sequence? What about decreasing sequence?
It should have lower bound.
Right. Let xn be, because tendency is decreasing. If nobody stops it, it will go to minus infinity. Right. If tendency of sequence is decreasing or sequence is monotonically decreasing like this, and if nobody stops it, it will go to minus infinity. And if somebody stops, means it has a lower bound, then it will stop there, it will settle there. So let xn be a monotonic decreasing. So if xn is bounded below, if sequence is decreasing, then bounded above is obvious, because first term is the upper bound, right? Because all terms are smaller. So if sequence is decreasing, then only question is whether it is bounded below. So if xn is bounded, then it is convergent. Right, so statement is clear.
sir.
Right, so and you should be able to see the situation. Should observe these two examples and see the picture. If sequence is going down, tendency is decreasing. If nobody stops, it has no lower bound, then it will diverge. But if it has lower bound or bounded below, then certainly it will going to settle down at some point. So it has a limit. Right. So how to prove this? Okay, we'll discuss proof later on. We'll first see the examples. Right, because proof needs some more ideas. Right, so proof is at this point proof is difficult, but anyway, we'll discuss proof later on. But statement is clear.
Yes, sir.
Right. So now for some sequences, it is not easy to determine or easily find whether sequence is increasing or decreasing. So there you need some more things. So anyway, let us see some examples. Xn, x1 is equal to okay, so x1 is equal to some okay, let us consider x1 is equal to root 2 and xn plus 1 is equal to root of 2xn for n greater equal 1. In this way, we define a sequence. Do you understand? How do we define the sequence? For example, what is x2? What is x2? What is x2?
Root over 2 root 2.
Square root of 2 root 2 because x1 is root 2. What is x3? X3 means what? X2 plus 1. That means n plus 1 is what? 2 square root of 2 x2. And so what is it? 2 of 2 into 2 root 2. Correct? So this is what x3 and so on. But this number is very complicated. Right? It's very complicated and where it is going to settle. Whether it's settled at some number or we don't know. Because if you keep on writing x4 and so number becomes very complicated number, and does this sequence going to settle or does limit exist, that we want to check, right? So first of all, is it monotonic? That's first question we can ask. Is it monotonic? Let us think about that. Means what is our question? Is xn less than or equal to xn plus 1 or xn is greater or equal to xn plus 1 for all n? Either one of them, right? Increasing or decreasing. That we want to check. Correct? So what is x1? Root 2. What is x2? Square root of 2 root 2. Which is bigger now?
X2.
Right. So now we want to observe here that x1 is less than x2. Is it clear why? Why it is true? Why it is true? Two is greater than one. So root 2 is greater than 1. Am I right?
Yes.
2 root 2 is greater than 2. 2 root 2 is greater than 2. Correct? And that means if you take square root of both sides, and ultimately what we get, x2 is greater than x1. So this is just simple observation. So x1 is less than x2 or x2 is greater than x1. Fine. Now we want to check that xn is less than or equal to xn plus 1. We expect here, because x1 is less than x2, we expect that if it is monotonic, then it might be increasing. So that we expect xn is less than or equal to xn plus 1. And for all n means natural number. So if you want to prove statement for all n, which strategy we should follow?
Induction.
Induction, right? We should use induction because we want to prove something for all natural numbers. We shall use the induction. So what is the first step? For n is equal to 1, x1 is less than x2. So statement is true, right? What is second step? What is induction hypothesis?
Assume that for n is equal to k, the statement is true.
Right. For n is equal to k, xk is less than or equal to xk plus 1. This we are assuming. For k is a particular number, and for particular step we are assuming. And what is the third step? Inductive step. So inductive step, what we expect next? What is the next?
For k plus 1, we have to prove that statement.
Right. So we expect that xk plus 1 is less than xk plus 2. Next, this is our expectation. We have not proved it. Right. So this is expectation. How to prove the expectations? So by second step, by induction hypothesis, so by induction hypothesis, we assuming that xk is less than xk plus 1. This is assumption that we can directly take, but we have not yet proved xk plus 1 is less than x. Okay, so this is true that we are assuming. Now multiply both sides by what? Multiply both sides by 2. Can I say that less equal again?
Yes, sir.
And one more thing, both are positive quantities, because square root we are taking, we have defined x n plus 1 is square root of 2xn, which is a positive square root, so positive quantity. So xk is positive, xk plus 1 is positive, 2 times is positive, so I can take square root, right, 2xk, and again I can take square root of 2xk plus 1. Can I say that inequality remains same?
Yes.
Yes, sir.
Yes, because in case of real numbers, we already proved that a less equal b if and only if square root of a less equal square root of b. if and only if a square is less equal to b square. So this basic property of real numbers for positive a and b we already proved. So but ultimately what is the left hand side square root of 2xk?
xk plus 1.
Right. So this is actually xk plus 1 and right hand side is xk plus 2. So if we assume xk less equal xk plus 1, we are able to prove that the next terms also follow the same inequality. Therefore, xk less than or equal to xk plus 1 imply that xk plus 1 is less than or equal to xk plus 2, and by induction xn is less than or equal to xn plus 1 for all n. Right, because one x1 and x2 satisfy this, and from k to k plus 1 step it is true, and therefore by induction at each step this is true. Okay, and therefore xn is what?
Monotonically increasing.
Monotonically increasing. And therefore next question one can ask is it bounded above? Monotonic increasing is fine, but it may go to the infinity. Right. If there is no number which stop these terms, then it might go to the infinity. So the next question could be, is xn bounded above? Right. So this is the question. So now let us check whether it is bounded above. So what is x1 is root 2. Right. What is x2 is square root of 2 root 2. Can I say that this x2 is less than 2? Is it true? X2 is less than 2. Is it true or not true?
It's true.
Yes.
Yes.
Right, because root 2 is less than 2, right? So that 2 root 2 is less than 2 times 2, which is 4. And if I take square root of this, then it is less than square root of 4, which is 2. So this is clear that square root of 2 root 2 is less than 2. That is obvious. We just want bound, upper bound, not necessarily 2 is the upper bound. So we have to just produce one upper bound so that we can say that it is bounded above. Right. And what we expect. Do you understand? We expect something. Can we expect 2 as upper bound?
Yes, sir.
Okay, this is our expectation, and for all n. So what strategy we should follow? Which strategy we should follow? Induction, right? Because we want to prove that something is true for all n. Right. So naturally, which strategy is useful? Induction. Correct? What is the first step for n is equal to 1? What is x1 is root 2 is definitely less than 2, or for n is equal to 2, x2 is less than 2. So for n is equal to 1, 2, it is true. What is next step? What is induction hypothesis?
नेट बंद होतं ना कळालंच ना
What is induction hypothesis?
For n is equal to k, this is
This is Ravi, right? Keep your mic off. What is the induction hypothesis in this case?
Assume that it is true for n is equal to k.
Means what? Assume that xk is less than or equal to 2.
Yes, sir.
Right. And then third step, inductive step. Right. So want to prove for n is equal to k plus 1. Means what? What we want to prove? The xk plus 1 is also less than or equal to 2. This we want actually. So not proved. So how to prove this? So by induction hypothesis, we are assuming that xk is less than or equal to 2. This is our assumption. Now can I, if I multiply by 2 on both sides, is it true?
Yes, sir.
So what does it mean? If I take square root of both sides, the inequality remains true. Correct?
Yes, sir.
But ultimately, what is LHS?
Xk plus 1.
k plus 1.
Right? Therefore, xk less than 2 implies xk plus 1 is less than. And for n is equal to 1, 2, it is already true. So by induction, xn by induction, xn is less equal to, because all xn's are positive. So we can say that absolute value for all n. But here xn's are positive, so no need of absolute value. Anyway, it is true. So, or here we don't need actually absolute value also, because we are just looking at upper bound. Right. So we are not interested in lower bound. So no ambiguity. So by induction, xn is less than or equal to 2 for all n. Hence, xn is bounded above. Therefore, by monotone convergence theorem, what can we say? What we can say? What are the properties of this particular sequence? Xn is monotonic increasing. Moreover, it is bounded above. So what we can say about this sequence?
Xn is
It is
convergent.
convergent.
Right. So Xn is definitely convergent, because monotone convergence theorem guarantees if it is increasing and bounded above, it is convergent. But the next question one can ask, what is limit? Right, because it is convergent, then can you find limit?
Yes, sir.
Right. Let us see what is limit. So note that. So limit n tends to infinity xn and limit n tends to infinity xn plus 1. Can we say that limit is same? Can we say limit is same?
Yes, sir.
Yes, and it is not difficult to see because x1, x2 and so on, xn plus 1. When I say limit n tends to infinity xn means I am just going to next terms, then where it tends. And when I say n plus 1, xn plus 1, just one step ahead, right? Xn plus 1 is one step ahead of Xn, but ultimately sequence is same, so terms are same. The destiny is same, right? As n tends to infinity or n plus 1, as n tends to infinity, what is the difference? What is the difference? Do you understand? Yes. Difference is when we say limit as n plus tends to infinity xn plus, this is one step ahead than limit n tends to infinity xn, but both are following the same terms. The destiny is same, therefore limit is same. Correct?
Yes, sir.
And one more thing, okay, that we'll see later on. So limit n tends to infinity xn is same as limit n tends to infinity xn because same sequence, only one step ahead. So we have xn plus 1 is square root of 2xn. Therefore, what is limit of xn plus 1 is limit of root of 2xn, right? Limit as n tends to infinity xn plus 1. Now, can I push limit inside square root?
Yes, sir.
Yes. And have we proved it before?
Yes, sir.
Right. See, if limit of xn is x and xn is a sequence of non-negative numbers, then limit of root xn is what? Root x, square root of limit of xn. This is what we already proved, right? That's why that theorem was important. Now we are sure we can push limit inside the square root. So therefore it is what? Square root of limit of 2 times xn. Okay, let x is equal to limit of xn. That means it is also limit of xn plus 1 because same sequence. Correct? Therefore, from this expression 1, what we get? What is the limit of xn plus 1? X, correct? What is it equal to right hand side? Limit of 2 xn. What is it? What is it?
2x.
2x. Because limit of constant times xn is constant times limit of xn. That is what we know. And therefore, if x is a limit, x satisfies this. Now squaring this, what we get? Squaring this, what we get? Correct? Yes. Is it true? Therefore, what is limit of sequence xn? What is limit? X into x minus 2 is 0 implies product of two numbers is 0 implies x is 0 or x minus 2 is 0, right? Am I right?
Yes, sir.
Yes, sir.
But x is equal to 0 is not possible. X is equal to 0 is not possible. Why? 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 Why x is equal to 0 is not possible?
Increasing sequence.
So all terms are greater than 1 and terms are increasing. So limit is greater than 1. Limit cannot go below 1 because the tendency is increasing and all terms are greater than 1. Right? So limit cannot be 0. That you should understand. So is it clear? Any doubt in this?
No, sir.
And therefore, what is the possibility remains?
X is equal to 2.
Right. And hence, limit n tends to infinity xn is 2. Therefore, where this sequence converges? This sequence converges to 2. Right. So that means if your terms are like this, key root 2, then right. So if you keep on increasing next term, so the situation is like this. So square root inside square root inside square root. So this is a situation. But where this number is going to settle at infinity, so this number is going to settle as n tends to infinity to 2. Even this number is looking very complicated, but at infinity it is going to settle at 2. So because limit of this sequence is 2. So is it clear?
Yes, sir.
Right. And therefore, just the process. Remember the process. We try to prove initially whether it is increasing or decreasing. So we saw that it is increasing, then we saw that it is bounded above, then we try to find out limit. So limit is 2 in this case. So each and every step is clear. So I will give some for exercises. So let x1 is equal to 1, xn plus 1 is 2 plus xn, or n greater equal 1. Then xn is monotonic. Second is xn convergent. Third question will be if s is limit. So follow all the process which we had in the previous example. Next example, okay, xn plus 1 is 3xn and x1 is 3. Then follow, repeat all above. Right. Repeat all above procedure for this sequence. Correct. Now one more, x1 is equal to 1, x2 is equal to 2, x. Okay, so xn is xn plus 1 is 1 by 2 into xn plus 2 upon xn. So you think about this and you try to prove whether it is increasing or decreasing. Repeat all above. Next time we'll see. Right, so any doubt?
No, sir.
Okay, so what we discussed today, everything is clear.